So the first problem with this assignment has to do with if you want to build a rectangular pen that has 3 parallel sections using 500 feet of fencing, and what dimensions will maximize the total area of the pen. So to begin with, you can draw a picture of it, which would look something like that. Because it's 3 parallel sections, I just assumed there's something on the other side that was causing another fence, like the problem we did earlier in the term. So we'll label that X, Y, and this is X. And then, with the information they gave us, they said that we have 500 feet of fencing. So you can put that with, there's 2x, and then plus y equals 500. And then the other equation that you need to come up with to solve this problem is very simple. It's the area equation, which is A equals x times y. So to begin with, you have to solve for the y in the 2x plus y equation, which would be y equals minus 2x plus 500. So then from there, you just sub that into the area equation. So that would be A equals x minus 2x plus 500, which then simplifies into minus 2x squared plus 500x. Then from there, with what you have right here, you need to find the derivative of that, which would be a prime equals minus 4x plus 500, which from there would go to 500 equals 4x. Then you simply divide the 4, and then x equals 500. So that is what x will equal to maximize the, whoops, never mind, that was a little typo. X equals 125. And then from there you just input that 125 into the equation that we had before with the 500, so that would be 2 times 125 plus y equals 500, and that goes to 250 plus y equals 500, which then just goes to 250 equals y. So those are the 2 dimensions that will maximize the area that the pen can hold. So the second optimization problem is a little more complicated. It has to do with finding a cylinder with using a cylinder that has a volume of 20 pi. You have to find the height and the radius that would give that would make the most economic cylinder. The volume, I said, was 20 pi. And then the volume equation would be pi r squared, height equals volume. And then they also gave us information that said that the top, for each material on the top, it costs $10 per meter squared, and then the sides is 8 meters per meter squared. That's very important to finding the answer to this problem. And then, based on these 2, you can set them equal to one another to figure out to isolate either the r and the h, but it's easier to do the h, so that's what I'll do. Equals 20 pi, and then that will just go to, once you do all the math, it'll go to 20 pi over r squared equals height. So the next step of that is using the surface area equation, which is 2 pi RH plus 2 pi r squared. You then substitute that h value in for the h in the surface area to find the answer. So that will be 2 pi r times 20 pi over pi r squared. I forgot the pi right there. Over pi r squared plus 2 pi r squared. So then to incorporate the prices into that, you just multiply each part by the price, and then to save some more room on the board, I'm going to just quickly fill in those values. So they'll be with prices, that will go to 16 pi r 20 pi over pi r squared plus 20 pi r squared. So now that we have that, we need to find the, we can further simplify that to make it equal, to make it a lot easier to work with. So that will then go to, the most simplified form that you can have is 20 pi squared r squared plus 320 pi over pi r. So from there, what you need to do is find the derivative. So I'm going to erase what I have so I have more room to work with. You can see that I'll put that back up on the board. Alright, so then from there you found the derivative, which will give you the value for which will give you the value for r, and then you just put that back in to find the value of h, which will give you the answer. So then the derivative of this would go to pi r over pi r 60 pi squared r squared minus 20 pi squared r cubed plus 320 pi times pi all over pi squared r squared. And that was done using the quotient rule. And then that, I'm going to skip the simplifying because there was quite a bit that went on. And that just goes to 40 pi cubed r cubed minus 320 pi squared over pi squared r squared. And then the next step is to set the numerator equal to 0, which will give us the r. And so from there, we do 40 pi cubed r cubed minus 320 pi squared equals 0. And then that simplifies to go to 40 pi squared. 40 pi squared pi r cubed minus 8. So then the next step right here is to figure out what part right here would make that entire thing equal 0. So using what I did was I just used my calculator, and that gave me a value of 1.36. So that right there is the radius that will maximize that'll make it cheaper to produce. And so then it's very easy to find the height. We just put it back into the equation that I found earlier and erased. So that will be 20 pi, which was 20 pi over pi r squared equals h, which went to 20 pi over pi 1.36 squared. Those cancel. And then using my calculator, I figured out that that went to 10.73 equals h. So those are the two dimensions that will maximize your profit making this. So the last problem that we have to do is the rectilinear motion problem that has to do with the equation t cubed minus 6t squared plus 9t plus 1. So the first part of the problem was finding the velocity, the initial velocity, and where it is stopped. So that's very simple. You just find the derivative of that equation, which would be dt equals 3t squared minus 12t plus 9. So that there is the velocity function. And then figure out where that is stopped. You just factor that, and that would make it 3t squared minus 4t plus 3. And then that there, this part factors into 3t minus 3t minus 1. So that means that the velocity is completely stopped when t is equal to 1 and when t is equal to 3. And then the last part of part A was figuring out the initial velocity, which is very easy. You just plug in 0 for t for the velocity function. So that would be v of 0 equals 3, 0 squared minus 12, 0 plus 9. And that there is clearly 9. So that is the velocity of the initial. So I had to erase my work. So the answers are right here. So the second part was just finding the acceleration problem and I can't remember how to phrase it. And the initial acceleration. So finding the acceleration function is very easy. You just take the derivative of the velocity function. So in this case, a of t equals 6t minus 12. And then to get the initial velocity, you just plug in 0. A of 0 equals 6 of 0 minus 12. So that tells you that the initial acceleration is minus 12. So then part C was finding the what it speeds up and slows down. So to do that, you use a number line for when it stopped and when you factor the acceleration function. So that factors into 6t minus 2, which then goes to t equals 2. So that was what you put on your number line. So the number line goes as followed. Make sure you can see this. So here, the first one up here, this is velocity, and this is acceleration. Up here, the first comes 1, obviously. Actually, first on the line is the minus, 1 is up first. And down here you have the 2. And right here you have your 3. And then to figure out the direction it's going on the 3, you have to plug in a number like 4 into this function. And when you do that, it comes out to be positive. So positive, positive, positive. And then where you got the 3 from was a negative exponent, so that would be minus, 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 changed. it's the same pattern on the acceleration part. This is plus, and then because there's a negative exponent of 1, I mean a negative odd exponent, it goes to minus. So then you just divide this into sections, and where it's the same sign, that's where it speeds up, and where it's different, it slows down. So right here it slows down, right here it speeds up, here it slows down, here it speeds up. So for that notation, it speeds up from 1 to union 3 to infinity, and then it slows down minus infinity to 1 union 2, 3. Make sure you can see that. So I'm just going to quickly erase this section, and then I will do the last part where I draw the distance from t equals 0 to t equals 5. Alright, to figure out what this particle that is moving looks like while it's moving, the distance that it has from t equals 0 to 5, t from 0 to 5, the distance actually. So what you do, you need to find your initial your starting position. You do that by plugging 0 into the original. You always plug into the original. So if t was to equal 0 right there, it would come out to equal 1. So at t equals 0, that's 1. And then from there you plug in every single point that you had on your number line. So I then had t equals 1, which ended up being 5 when I plugged into the original. So that's t equals 1, that's 5. Connect the line. And then at t equals 2, which I had from the acceleration part, I plugged that in, and I ended up getting 3 at t equals 2. And so that changed direction, so it loops up. And then at t equals 3, which is in the velocity part, I plugged that in, and I got it to equal 1 at 1 as well. So that equals t equals 3. And then to finish it off, you can just plug in t equals 5, which ends up actually going all the way over here to 21. So then to figure out the distance, you just add all of that up. So this right here would equal 5, and that second part equals 5 as well. And then, actually, never mind, didn't start at 0. Sorry, so that would be 4 plus 4, and then the distance from 1 to 21, which is 20. So that plus 20, which then equals 28.